Everyone, here I am Vadil Sagar and warm welcome back to our discussion regarding the chapter number 1 of the standard 12. So at the end we take a stop at the part number 9. Now here in the part number 10, yes, you can able to see this here, and then this is electric charge and field is the chapter. So if before I am starting to the chapter part number 10, you must seen that part number 9. Whatever today we will discuss, it is the particularly and completely based on part number 9 discussions and all equations and all that. Okay, let's, it is what the slide you have, it is the end of the story of the part number 9. Part number 9 is nothing but the little bit I am revise you, and also I am mentioning the link of the part number 9 below in the descriptions, so you can go before seeing this video in the part number 9, and only after this you can able to see this video. Okay, so it will be beneficial to you. So part number 9 is regarding the field of electric dipole. So electric dipole, you know, it is a thing which is made up of the negative charge and positive charge 1 1. They are separated by this particular distance, and if they are not separated by the distance, then it is not a dipole. It should be separated by the finite distance. Okay, then it has a dipole moment. It is a own characteristics. That is, dipole moment is nothing but the P capital Q multiplied by 2a. What is 2a? 2a is the distance between two point charge. It can be 5 centimeter, it can be 5 mm also. Okay, and then Q is the charge. Those two charge which is separated by the dipole, both are always same. So one of the charge you can able to take here. This is called dipole moment. And those are the expressions for the what? The dipole moment. Dipole, it has electric field because charge had electric field. So this is a two charge system, and it has own own electric field. Okay, now if this electric field, if you measure at the particular, as I said you in earlier also, that electric field is depends upon the place to place where you are in the space. Okay, so if you are in a dipole axis, so those things must I am discussed already in detail in the ninth part, but this what we discussed today, it is a constructions based point of view we are discussing here. This set of equations is electric field equations for the when our point of observations of electric field along the dipole axis. What is called dipole axis? You can go in the part number 9. These are the equations electric field for this particular point of view. And this set of two equations, actually this is a reductions of this equation. How? The 2qa is equal to, you can put a p. 2qa if you put, then 2p. Okay, and 2qa it is itself is p. So this is the reductions of the above equation, nothing more than that. But this set of equations is for the when our point of observations of electric field is on equatorial plane of the dipole axis. What it is? Go back to the 9 part. Okay, this is what it is. The already we construct these equations. This set of equations is there is a huge mathematical steps are there, set of mathematical steps, that on the end of the story we will get this, we got in the chapter number. Okay, now we are in the example 1.10. This example is the nothing but the refreshments of the what we discuss. So if you have a clear cut idea or the clearance in the part number 9, then and then you will able to get the idea and what we are trying to discussing in this point. You get the example number 1.10. There is a two charge, which is a plus or minus 10 microcoulomb are placed at the 5 mm apart. Okay, so these two charges are the far apart, in between 5 mm distance are there. Determine the electric field. So we have to calculate electric field at the two option A and B. A is the a point, a P on axis, and B a point on equatorial. We will see the diagram point of view, they are given in the question also. So this is what the P on dipole axis. This is called dipole and it has axis. So on axis anywhere point is there, their equations for the finding the electric field is also be derived, so that we will use and solve this example. And particular for this, okay, now we are focusing a point only, a task only. Then dipole is the 15 centimeter away, so dipole center to that point is the 15 centimeter away. This is 15 centimeter. Is it okay? Away from the center O, that is the side of the positive axis also, so it is a also towards to the positive charge. Okay, this much information is enough for us. Okay, let's go for the calculation point of view. That AB, what is called AB is a 5 mm. It is a converted into the SI unit, so it is a meter, so it is a 0.5 centimeter. It is a very easy to understandable. Now you are in the 12th class. Now it is a centimeter to the meter, so sorry, I'm here I'm forget to put the m because of m of meter, but centimeter goes into the meter, 10 to the power minus 2. This is a AB, but we want this center distance from the O to B distance, from O to A distance is always same, is a half of the AB. So AB divided by 2. So this is your AB and divided by 2, it will be the 0.25, 10 to the power minus 2. This is help you to, for the further calculations. This is A. Wherever you have in your calculations in equations, here you can able to see that A. So this is your, this is whole is to A, this is your A. Is it able? Okay, is it able to understand? Okay, so this is r is the distance from the center to this point. Okay, this is how much? 15 centimeter. Okay, let's start to the discussions. A, filled at P point on the side of 10 microfarad. Okay, due to the field filled by the point P, due to the presence of one of the charge, particularly we are taking in the first case plus 10 microcoulomb. Okay, so this equation we have, you go back into the ninth part discussions, you will get in the first few slide, you will get this equation. E is nothing but it is just E is equal to Q, K Q by R square you have now. This is a set of form, but the R is modified, R minus A, because this is R is from the center to this, but actual distance between this point and this point is this much, so this is total R. Then you have to cancel this A part. This is the R minus A. If you still you are having confusion to how this equation comes, you can go into 9 parts. Okay, so now it is a q 4 pi epsilon 4 pi epsilon 0 r minus a whole square into the p cap. P cap is the nothing but the shows of the directions point of view, so there is a no more need to focus in this part. It is okay. Now we are just okay here, one line, it is a denominating line is there. Q is equal to 10 to the power minus 5. How? 10 microcoulomb. So the micro is 10 to the power minus 6. The 10 into 10 to the power minus 6, it will be 10 to the power minus 5. So this is a Q minus 5. 4 pi epsilon 0 is 8.85 into 54 into 10 to the power minus 12. This is a 1, it's nothing is there, so why I'm putting 1. So the 15 is the R as 15, 10 to the power minus 2. I'm taking common on the side, but the whole 10 to the power minus 2 square, so it will be 10 to the power minus 4. A is equal to 0.25, so the 0.25, 10 to the power minus 2, 10 to the power minus 2 is go outside of the with the square, so it is 10 to the power minus 4. If you do in the calculation in a calculator, you will get the 4.13 into 10 to the power minus 6 Newton Coulomb inverse along the BP line, because it is a positive charge, so it is always radially outward, as always radially outward, so the along the BP line you will get this much electric field on P point due to the plus 10 microcoulomb charge. Okay, now we will focus on the field on P due to presence of that minus 10 microcoulomb. Okay, so this is what we have. So go in the 9 part, you will get the E minus Q is equal to Q 4 pi epsilon 0 RA plus, because R is the distance from this center to this, but the distance from the A to P is the R plus this part is A. So this is but nothing but the total distance is R plus A square. Now put the respective numbers only. Take care regarding this minus sign. It is showing that it is contributing to the negative side of this. So electric field is this direction, the electric field in this direction. Okay, So put the respective numbers only and you will get the 3.86 into the power 6 along the PA line. See, PA line, PA. So this is the opposite direction. This negative sign is indicating opposite direction point of view. Okay, there is a no number negative. Okay, so that's why at the end they are not putting the number negative. Otherwise at the end if you see the resultant electric field on point A, it is nothing but the sum of the due to positive charge, sum of the due to negative charge. So if you summed up, then this is a negative number, this is positive number, so ultimate is reduced. That is not a case. Okay, the resultant electric field on P due to the A and B both 1, so it will be the this is also here. This is what we have along the axis resultant by the adding both 4qa upon 4 pi epsilon 0 r cube. How r cube comes, go back into the 9 parts. So this is what you have. Now if you put the 4, q is equal to 10 to the power 5, a is equal to 0.25 into 10 to the power minus 2, 4 pi 8.85 into 10 to the power minus 12, r is equal to 15 centimeters. So the point 15 into 10 to the power minus 2. Otherwise if you take direct 15, then you know direct 15, then 10 to the power minus 2. If you take point 15, then it is not a directly convertible into the meters. So this is now you are in the 12th, so you have to do this calculation and you will get 2.7 into 10 to the power 5. So what is the meaning at the end? You understand anything? So this is what electric field. Okay, 3 electric field we get, but what the 3s? So this is due to this on this now in this point on this point. Okay, this much is due to this on this point. Now this number 2.7 into 10 to the power 5 is on this point due to this whole dipole. Okay, is it okay? Okay, this is the physics. So why the peoples and why students are facing difficulty in understanding of the physics? Because they are at the end they are not understand what they find. If you understand the proper equation is not just an equation is has own manipulation. You have to able to understand these things. Equation is nothing like a just the quantities q 4 pi r a. No, it has meaning. Try to see inside the equations. Try to that one line by someone who very great fellow, that I forgot his name, but he said the read the sentence between the words. now उसका मीनिंग आप निकाल लो. Okay, let's go for the B task. Okay, before B task, one more the thing is there. Yes, in this example, the ratio of OP and OB is quite large. What is OP and OBC? OP, OP and OB. Why? Because one OB is A and OP is R. The ratio is very quite large. Thus, we can expect that to approximate the such as equations by this condition. R by A is very greater than 1. It is 60. So, it's a greater than 1. So, we can reduce our R minus A and R plus A to the only R. So because this is very nominal, a distance is very in the few mm and this is in the centimeters, so we can neglect the a. And if you neglect the a, so our reduction, our equations is reduces to this using E is equal to 2p 4 pi epsilon 0 upon r cube. Let us see if we are neglecting a part, then how much it contributes. Okay, using this equation, E is equal to 2p 4 pi epsilon 0 r cube, where p is equal to 2qa. If you want to put the p value, then what is the 2q? Q is equal to 10 to the power 5 and 5 into 10 to the power minus 3. What the 5 into 10 to the power minus 3? It is a total 2a distance. 2a is the 5 mm. 5 mm, if mm is goes into the emitter, 10 to the power minus 3. And this is a overall dipole moment of the dipole. Now 2 is there, dipole moment P is there, 4 pi epsilon 0, for epsilon 0 r cube. This is your r cube. R is the 15. So the 15 into 10 to the power minus 3 in the meter. And this is the square. Oh sorry, 15 into 10 to the power minus 2 and whole cube. So cube, the 2 in the cube is 10 to the power minus 6. This is very able to understandable. So this is a reduce your answer to the 2.6 into 10 to the power minus 6, 10 to the power minus 5. Okay, so what the answer is here, 2.7 into 10 to the power 5 by the not reduction in this equation in a dipole moment. Oh, the 2.6, just 0.1 electric field we get a reduction if we neglect the r, if we calculate the electric field using dipole moment. So along the dipole moment is the ab, which is close to the result obtained earlier what we has. Okay, the dipole moment is always towards the negative to the positive side, and electric field is always positive to the negative side. This is this thing you have to keep inside your mind. B task, a point q which is not on dipole axis, it is somewhere else on the space. So their calculations of electric field is something different way. So from the point o on the passing through that axis normal to the axis dipole as shown in the figure 1.12, it is the this case we have for the particularly the find q due to the find a field at q due to the positive charge, this charge. This equations is also we seen in a detailed in the part number 9. So please see the part number 9 first, and then you come back to this here. E plus is equal to 10 to the power, okay, this is the equation, put the respective menu. Here we have one line, denominating line, 9 10 to the power q is equal to 10 to the power minus 5, 4 pi epsilon 0, 8.85 into 10 to the power minus 12, 1, r is equal to 15 mm, oh sorry, 15 centimeters. So 10 to the power minus 2, that 10 to the power minus 2 come outside. A is 0.25 10 to the power minus 2, it come also outside, and the whole square, so 10 to the power minus 4. If you do any calculation in your calculator, you will get the 3.99 into 10 to the power minus 6, not a minus 6, plus 6, sorry, 10 to the power 6 along the line of BQ, because the it is a radially outward, so this is along the line BQ. Okay, now if you find the field on the q by a, it is this direction. So this and this will be the cancelling each other, we will see detail. This is also detailed discussions in the part number 9. So again, these equations we are taken from the part number 9 discussions, and we are just putting the numbers q 4 pi epsilon 0 and then 1 upon r square, both for the r plus a, how it comes, go back into the 9, 15 10 to the power minus, okay. So you will get the 3.99 into 10 to the power 6 along the QA. Why it is a Q2A? Because it's the negative charge, so it is radially inward. Is it okay? Inward. Okay, so clearly that components of the two forces are equal in magnitude, 3.99 10 to the power 6 along the BQ, and the 3.99 10 to the power 6 along the QA. So the both components are the cancelling each other along the directions of the line of parallel to the BA, and therefore the resultant electric field on Q is also change at the point A and B. So this is what we discussed in the part number 9. Here I am taking for this exactly this figure is reversed for us. How? Let us see. Because they are putting negative charge on the left side, positive charge on the right side. So here negative charge on the left right side and the positive charge on the left side. So this is the set of electric field in this side, nothing more than that. So you can able to see in this side, but the understanding behind the physics, it is the same. So this is a resultant electric field EQ, what we find here, EQ, and this is a E plus, what this is the time, it is here, it is here. So if we reduces your EQ plus and EQ minus into the its component sign and cos, so EQ plus sign, EQ minus cos, okay, EQ minus sign and EQ minus cos. So this EQ plus sign and EQ minus sign, it will be cancelling each other upside downside because the magnitude are same. So this is the double time of the EQ plus and EQ minus cos components are resulting. So resultant electric field on the point P or on the point Q for our example point of view. So this is the electric field is the 2 time of electric field of the cos component. So this is a 2 time of electric field E of cos component, 2 q 4 pi epsilon 0 1 upon r square cos component of p cap. This is cos. You can apply this our understanding of the Pythagoras and then the trigonometry. Cos, you will get these numbers, This is what we needed. 2q 4 pi epsilon 0 r plus square. The 2 is here, the q is equal to 0.25. Okay, so this is a whole number we are used. 2q by 4 pi epsilon 0 r plus r square. Okay, see, this is all we find it. Q upon r 1 upon 4 by r square plus a square. This whole number we get already. So we are whole this equation we used as a 3.99 10 to the power 6. So this is 3.99 10 to the power 6. What the things is left? This. So this is a is 0.25, r square 15, r square a square is 0.25, a square raised to 1 by 2, that is 1 by 2 is under root of it. If you find the number, you will get the resultant electric field in the directions of this. For our point of view, for our example point of view, is this. Is it okay? Okay. So this is the E is equal to 1.33 10 to the power 5 Newton Coulomb inverse. It means Newton per Coulomb along the B to A, because the positive to the negative always. Okay, so this discussions also we reduces to the dipole moment point of view. At the first slide of the discussions, here this electric field is reduces to the E time minus P upon 4 pi epsilon 0 r cube, and this is what we use at the end. Here E upon 4 pi epsilon 0 r cube, P you are using 4 pi epsilon. What is P? Dipole moment 2aq. Q you use that we find already. 4 pi epsilon 0 15. Okay, number of time numbers I'm not repeating number of, so that 1.33 into 10 to the power 5. So 1.3 to 10 to the power 5. If you are going in this way also, see here how much task you done for this finding the 1.33. You are finding positive number, positive charge, negative charge electric field, and you are doubling out, and then you are doing this much task, and then you reaches to the 1.33. Instead of this, if you just use this dipole moment equation, you will directly reach at the second step, you get the answer. But sometimes you got a very less in error, so this can be neglectable. So you can, if you have a same task in a MCQ, then you have to not take this those equation, you have to go with the dipole moment point of view. So this is the E is equal to 1.33 find the directions of electric field is the case of opposite to the directions of the dipole moment vector. Again, as I discussed, how see this is a okay, this is the directions of the dipole moment. Is dipole moment is always towards to the positive side and away to the negative side, and electric field is always out to the positive and accepting to the negative. So this always dipole moment and electric field direction is always opposite, as we discussed in earlier case. Thank you very much.